We have lesson 1.5, day 1. Solve with variables on both sides. Our objective today is write and solve equations with variables on both sides. But when I'm talking both sides, I mean both sides of the equal sign, okay? Really, mainly we've been dealing with just either my x or my y is on the left or it's on the right of the equal sign. There's never two, okay? We're going to talk about when there's two variables on both sides, okay? So our key idea here, solving equations when there's variables on both sides. To solve an equation with variables on both sides, use inverse operations to collect the variable terms on one side. Inverse operation of addition. What's that? Good. Addition gets undone by subtraction. What about subtraction? Inverse operation of that? Addition, right? They undo each other. What about division? Good. If you want to put a dot or a star for multiplication, don't put an X because then it looks like a variable X. Okay? So I'm good with dot, parentheses, or a star. Okay? So those are inverse operations. That's what they're talking about when they say inverse operations. We want the variable on one side and the constant terms on the other side. What's another word for constant? Does anybody know? X. It's actually, no, variable is an X or Y. Constant, anybody know? What is it? Sorry, one more time. Yeah? Okay. So this guy would be our number. So if there's a number with no variable attached, that's a constant. That's the one we want to get away from the X or the Y or the N or the P, whatever letter we have. Okay? And then just like before we isolate the variable, and we do it just like the beginning of the chapter did. So looking at the solve and check. Ooh, keeps popping down. There we go. Solve and check. It says 10 minus 4x equals negative 9x. If it's helpful, actually, whether it's helpful or not, keep that equal sign like in line with each other. A lot of the times, you just being disorganized kind of messes us up sometimes when we're trying to solve something. So if you keep your equal sign underneath itself, that'll help, okay? So I'm going to draw I highlighted it just so you guys can see what I'm talking about. I want to move, I have a negative 4x or a minus 4x on the left. I want to move that over to the other side, okay? Well, I need to get it to be 0 there. So negative 4x, I want it to become 0 x's. What do I do? Yes, add 4x. Perfect. Write 4x underneath there. Plus sign. Don't leave out your operation. Okay? And now this is a balanced scale. Okay? I added 4x. This side got heavier. What do I have to do to the right side? Add 4x. I have to balance it. Okay? I put plus 4x. That's showing my work. I'm going to draw a line so I know, okay, I got to do that calculation. And then I have 10 left on the left side, equal sign. And then what's negative 9x plus 4x? Good, negative 5x. Remember, they're like terms. The x stays x. That's what makes them like. That's what makes it able to combine. All we have to do is look at the coefficient. Negative 9 plus 4 gives us negative 5. Bless you. Last step here, what do we do? Good. Divide. Create. This line that I made that means divide, okay? So write that line underneath the negative 5x, okay? And we're going to write negative 5. In order to get rid of multiplying by a negative 5, I have to divide by the negative and the 5. I can't just do it one or the other, okay? And just like before, keep that scale balanced. What's 10 divided by negative 5? Negative 2. What's negative 5 divided by negative 5? 1. Good. Do I have to write 1x? No. Box my answer. And we're going to plug it in and check and make sure it's correct. Plugging it in requires copying the exact problem above. And anywhere I see an x, notice I put parentheses. Okay? Because we talked about in previous sections, When I don't put parentheses, sometimes it looks like it's not multiplying. It's a minus, or it makes it a longer number. And so if I'm trying to multiply it, I gotta throw those parentheses around it, okay? We think it's -2, so that's what I replaced. And let's check out the left side. We have 10 minus 4 times -2. Order of operations, I have to multiply first. -4 times -2, what do you get? 8, okay? A positive, right? 10 plus 8. What's 10 plus 8 gonna be? 18, okay. What is -9 times -2? 18. So is this a true statement? Yes, it is. If you want to go all the way and say 18 equals 18, that's fine. If you write the word true, that's fine. Just show me that you checked it, okay? Okay, number 2, 5p equals 24 minus 3p. I have a left side with 5p and a right side with a constant, which is 24, and a variable, which is minus 3p. I want to move the minus 3p. How do I get rid of it? Make it 0 on that right side. Bless you. Add it. Yes. Should I just add 3? No, I have to have the p. Good. Plus 3p. Write your operation. Draw your long equal sign. Remember, when we are doing things vertically, that long line underneath a plus or a minus 3p in this case, okay, means equals. And so 5p plus 3p, 8p, right, equals 24, because now that 3p is gone. Last thing we have to do, divide by 8. Excellent. What's 8 divided by 8? 1. Good. We don't write 1p, we just write p. And 24 divided by 8? 3. Awesome. Let's plug it in and check. 5p, I think, is 3. I'm going to put parentheses so it doesn't look like 53. Equals 24 minus 3 times 3. Again, putting parentheses around it so it doesn't look like 33 on accident. Okay, let's check it. 5 times 3. Good. And then do I have to subtract first or multiply first? Multiply. What's -3 times 3? -9. Does 24 minus 9 equal 15? All right, then it works. You can write 15 equals 15, or if you want to just write the word true, that's fine as well. If it was false, remember, that gives me a hint. Hey, go back up and check. Maybe we just messed up our negative sign or something, okay? Can I scoot it up? Are we good there? Okay. Let's look at the next one. 2x minus 1 equals 5 times the sum of x and 4. I'm going to zoom in on this guy here. Okay? This side is good. Yes, I like what you said. What did you say? Distribute that 5 to both the x and the 4. All right, so I didn't do anything with 2x minus 1 or the equal sign, but we did have to distribute this other side first. Make sure distribute means multiply, okay? So we had to do 5 times x, 5 times 4. That's how we get our 5x plus 20. All right. Now before, in the other two, I had one side with just a variable and the other side with a variable and a constant. In this example, I have variables on both sides. I have constants on both sides. I don't care which side you move your x's to, okay? It's your preference. Math is all about problem solving. There's lots of different methods and ways to do it. So you do it what best suits you, how your brain sees it. Me, I always move the smaller variable over to the bigger one. That's just what I like to do. It doesn't have to be done that way. If you're like, nope, I like keeping all of my x's on the left and my constants on the right, totally fine as well, okay? I'll do it both ways since we have 2 more, okay? So in this way, I'll move my 5x first. So I'll get them all to the left and then I'll do another way. Either way, it's still gonna get me the same answer, okay? So if we wanna move this 5x, okay, I wanna get rid of it. I don't want any x's on that right side. How do I make 5x 0? Yep, subtract just the x. Good. Subtract 5x. All right, minus 5x underneath both the 2x and the 5x. And I'm going to highlight my sides, okay? Because there's a left side and a right side of that equal sign. So 5x minus 5x, that gave me 0 on the right side. On the left side, I have 2x minus 5x. What does that give me? Negative 3x. Good. Did we touch the minus 1 at all? Did I move the 20 at all? No. We can. All right? I can do it in this step right now. I can bring them down and write it in the next step and separate it. It's however way is organized and helpful for you, okay? I'm going to write it in 2 separate steps for now, and then I'll start joining mine in 1 step, okay? So I brought down my negative, I brought down my 1 on that left side, and I brought down positive 20. Do I have to write a plus sign in front of the 20 if it's positive? No, I just write 20. If it was a minus 20, would I have to write a negative 20 there? Yes. Okay? So just be careful with things like that. All right, what do I do next? Still trying to isolate that variable. Add 1. Good. Plus 1, plus 1. Okay? Negative 1 plus 1 is 0. I still have a negative 3x on that left side. And what's 20 plus 1? 21. Good. Last step, what are we going to do? Nice. Divide by negative 3. Divide by negative 3. Okay? We had to divide because that's how you undo multiplying by negative 3. So what's 21 divided by negative 3? Negative 7. Awesome. Let's plug it into the original and check. Anywhere I have an x, I'm going to replace it with the number negative 7. And since I have quite a few x's, I have 2 of them this time, I put parentheses where they were, and I filled it with negative 7s. And then we just have to check that both sides equal the same number. So the left side seems less complicated, so I'll do that one first. 2 times negative 7, right, negative 14, minus 1, negative 15 on that left side. And then let's check this guy. I have 5 times negative 7 plus 4. Inside the parentheses, I have to combine those first before I multiply them by 5. So what's negative 7 plus 4? Negative 3, and then times it by 5? Negative 15. Awesome. So do they equal each other? Yeah, so that's a true statement, and we're good to go. I'm going to keep that one in line in the same picture so we can reference it if we need to. This next one, on both sides, I have stuff being multiplied. I have stuff in parentheses. So we have 2 times the difference of 3n minus 4 equals 0.5 times 10 minus n. Okay? So just like we did with the 5, can we distribute it? Yeah? Okay? What we got? When you distribute that 2 to both the 3n and the negative 4, who can tell me? Nice. 6n minus 8. Awesome. Okay? And then do the same thing with the 0.5 to the 10 and the n. What do we get when we do 0.5 times 10? Nice. 5 minus 0.5 n. Perfect. Okay? If somebody wanted to write 1/2 n, is that the same? Yeah. Okay? So last time I decided, okay, I want all of my x's. I want my x to be on the left side. This time, I'm going to show you, it doesn't matter what side of the equation you put it on. I'm going to move it over to the right side this time, okay? So I'm looking at this 6n. How do I get that to be 0n? Subtract it, yeah. Minus 6n. Minus 6n. That gives me 0n minus 8. Well, that means I just have a negative 8 left on that left side. On the right side, I still have the 5. And now I have to do this calculation. Negative 0.5 minus 6. What does that give us? Remember, it's negative 0.5, not positive. Good. Negative or minus 6.5 n. Okay? My n is on the right side. I want to get rid of that constant of a 5 on that right side as well. How do I get this to be a 0 here instead of 5? Subtract 5. Let's do it. Minus 5, minus 5. Good. That gave me 5 minus 5 was 0. So now on that right side, I have negative 6.5n. And on the left side, now I have negative 8 minus 5. Nice. Positive or negative? Ooh, careful. We're subtracting, not multiplying. Yep, sorry. I was looking at the wrong. So negative 13? Okay. What's the last thing we got to do? All right, go for it. Divide by negative 6.5. Now, when you divide a negative by a negative, that will give us a positive number, okay? And what positive number do we get? 2. Awesome. Box it, and let's check it. All I do to check is I copy that exact same equation from the very beginning before I distributed. And I leave blanks for my ends, and now I'm going to fill it in with the positive 2. Positive 2, positive 2. I didn't put parentheses around that last positive 2 because it was subtracting. So it didn't really need any parentheses, okay? And then we just check and make sure both sides are equal. Well, parentheses I have to do first, so inside my parentheses I have 3 times 2 minus 4. Multiplication first, so 6 minus 4. That gives me 2 times 2 gives me 4. And then on this side, the right side, I have 0.5. But inside the parentheses, I have 10 minus 2. I have to do inside the parentheses first. 10 minus 2 is 8 times my 0.5 gives me 4. So that winds up being true as well. When you're ready, turn the page. I know, one more, okay? This last one looks scary because we have this fraction being multiplied. But guess what? We just did that with a decimal. It was no big deal, okay? So we could do it with a fraction as well. No big deal. We have 3 times the difference of 3 times x and 4. And that's equal to 1/4 times the sum of 32x and 24. So let's start and distribute, okay? Distribute your 3 to both the 3x and the minus 4. Do that. Get your calculations, compare with a neighbor, okay? Make sure you guys are on the same page with that. And do the same thing with the 1/4 times 32x and 1/4 times 24. Make sure that at least that step is on track. And then you guys could probably just keep going with it if you feel confident. A great question on this side of the room. It was asked, can I change this 1/4 to a decimal? Is it a nice decimal? It's not repeating, right? Yeah, how can we change that? If we didn't have a button that changed it for us, what could we do with the 1 and the 4 to find the decimal version? 1 divided by 4. Perfect. So absolutely. If you prefer working in decimals, go for it. Okay? Nice. So, let's see. I got 9x minus 12. And that was equal to 8x plus 6. Everybody get that for their first round? Okay. Did you guys move, well, do you want me to move the x to the left or the right side of the equal sign? It doesn't matter. I heard right first, so I'm going to go right. But you can move it left, okay? You will see we get the same answer. I promise, okay? So I'm going to move it to the right. That means I have to minus 9x from both sides. Bring down my negative 12. 8x minus 9x means I have a negative x. And I still have that plus 6. For me, my next step would be what? Yeah, subtract 6. Okay. Now I have negative 18 equals negative x. Well, if negative x is negative 18, what's positive x? Positive 18. Yes. All we're doing mathematically is dividing it by negative 1 just to get rid of the negative sign. That's all that we're doing mathematically. If you got your x to the left side, you would have stayed positive and not had to do that last step. So sometimes I will look ahead and see, what's going to keep my x positive where I don't have to deal with a negative x later? So that's also another way, kind of different paths and why I would choose one over the other. Did this check work out when we plugged it in? Yeah, let's say 3 times 3 times 18 minus 4, and that should be equal to 1/4 times 32 times 18 plus 24. If we calculate the left side, you should get 150 when you do order of operations. If you're not getting 150, just call me over. I can help you. And on the right side, we actually also get 150. So that guy works, okay? True statement.